Our surroundings are a collection of opposites: the rigid steel of heavy machinery, a flowing river, and the breathable air filling the gaps between. These materials appear physically unrelated. However, they are different expressions of the same underlying category. Scientists classify all of these as matter. This definition requires two specific things. The object must possess mass, and it must occupy a specific volume of space. A pile of coal provides obvious, visible mass, but the air around these workers also meets the criteria, taking up space and having weight. Understanding the universe requires looking past these large-scale shapes to find the internal rules that govern all mass. Every physical object is composed of tiny, individual particles. The way these particles are arranged determines how the material behaves. In a solid, particles are packed tightly together. Strong attractive forces lock them into a rigid grid. This internal lock prevents the particles from moving out of position. Pushing on the surface does not change the arrangement, which is why solids maintain a fixed shape and volume. If those attractive forces are weaker, the particles can slide past one another. This creates a liquid. Because the particles can slip and slide, a liquid flows. It takes the shape of its container, while the total amount of space it occupies remains constant. When attractive forces are nearly non-existent, particles fly freely in all directions. There are large empty spaces between them. This is the gaseous state. These particles will expand to fill the entire volume of any container they are placed in, having no fixed shape of their own. A substance's physical state depends on this internal spacing and the strength of the attraction between its particles. We can clearly observe these microscopic gaps through compressibility, the ability to squeeze a material into a smaller space. A solid piece of wood cannot be compressed because there is no significant empty space between its particles. Gases are highly compressible. The massive gaps between their particles allow us to force them much closer together. These industrial cylinders are designed to take a large volume of gas and compress it into a small, portable container. This process uses energy to force the particles into a tighter arrangement, leaving the matter itself unchanged. In liquids and gases, particles are never static. They are in constant motion. When particles move from an area where they are crowded to an area where they are spread out, the process is called diffusion. This occurs without any stirring or mechanical help. The ink gradually spreads through the water until the particles are evenly distributed. Gases can diffuse even faster than liquids. Their particles travel at higher speeds through much larger empty spaces. Diffusion provides physical evidence that matter is composed of moving parts, constantly traveling until they fill the available space. The spacing, motion, and attraction of invisible particles dictate the behavior of everything we interact with. Objects that appear solid and unchanging to us are actually organized collections of these discrete, microscopic units. These rules govern more than just laboratory samples. They control the interaction of land masses, oceans, and atmospheres across the entire planet. From a single drop of ink to the scale of the Earth, matter is defined by its particles, and those particles are always in motion.